Alrighty. So we are back. Welcome everybody back to the show. I'm here with Florin, and we're going to be continuing the work from last time on this sort of video keyframing and entering those keyframes into the vector database, which is sort of where we left off, right? Is getting that
Yes. Hey, everyone.
connected.
Yep. Hey, Kevin. So, yeah, basically, last time we managed to get the video processed, and now it's the time to do something useful with that information. Let me share my screen before we can start doing all of that. This time around, you should hopefully be able to see my whole screen. Let me know how it goes.
It's a little bit zoomed in.
Well, I'll. I'm
But
not really
it,
sure what to do
yeah,
in
it's
that
doable.
case. Okay, cool. So, you've also sent me a newer training file that we can use, and this one is a bit smaller, like 5 MB, so we can definitely clone this and have this reproducible. And I had to make some changes since we last saw each other, because one thing that I realized is I don't need the full context length here for Olama
Okay.
that we originally had, nor do I want to have at most 4 models running in parallel. That is because now I'm on a different machine. So um, I had to make these tweaks. I'm not sure if I'll commit them or not. We'll see. As for the maximum loaded models, I may have to change this to 1 depending on the models and so on. But let's see how that goes.
Okay.
So last time we were here, we basically had to spin up Olama. Let's do that again to make sure that everything is clean. So we say make Olama up, and you can see Olama seeing all the error message. Oh, sorry, the log messages and so on.
Yep.
And now, if we go here, example one, example 12, step one, we see that it's running and it's producing frames and so on. Now, one side effect of us changing the training video is that I should probably go and remove the extra frames that this will output, because we don't want those to be there.
Okay.
And yeah, this would be something that you'd need to take care of and make sure whenever you process different videos that those are removed. Although I do think, have we changed this? Oh, we did manage to do that last time. We were careful enough to just say remove everything.
Yeah.
So,
Yeah.
okay, that should be good. So we should have everything that we need under one roof here. Doesn't seem to have worked, but oh no, it did work. We are now describing the image. Perfect.
Awesome.
So, as you can see, it's a bit slower. Just like last time, I guess it's either the model or something else that we would need to potentially look into, but hopefully this shouldn't hamper our efforts too much.
Okay.
Okay, let me get the volume turned up a little bit. How do I do that? Here. I'm on this new fancy machine that I don't
Is
really
it
know how to use.
how much memory is this machine?
So this machine has 48 gigs of RAM,
Okay.
and it's unified, so it allows it to dynamically allocate from the RAM it has available to the GPU as well, which it's nice if you don't use the full system memory, right? It
Mm-hmm.
allows you to spend more memory to the GPU. So in theory, you could either run on bigger models, or you could run faster because you offload less layers from the model into the system memory, right? And you
Got
can
it.
see
Okay.
here in the system messages that from Olama that it says, oh, I've offloaded these many layers to the GPU, and technically all of them are within GPU because it has enough RAM to do that. It detected that the model is like 5 GB or something like that when it loads it.
Hmm.
Just the model waits, and then it assigns some of those to the CPU as well because the CPU still needs to do some work. And then there is some computation graph that will happen based on your maximum context size and all of that, just to make it able to run faster. So in our case, we are using something like 5.3 gigabytes plus 4.4 for a total system memory of oh, and I forgot about the KV cache, of course. So this is the key value cache for the prompts, and that's another almost 2 gigabytes for a total of about 12 gigabytes. So the model technically could fit into a GPU with, let's say, 16 gigabytes of VRAM and still allow you to get some of that memory to other applications and so on, like the system itself.
Okay. Cool. Yeah. That's interesting. I wasn't really sure what a lot of those sort of logs were. That's
Yeah,
pretty
I
interesting.
guess
Yeah.
we skipped them last time, but yeah, I'm happy we had to go through that. Unfortunately, like last time, we still have some problems with the model itself not wanting to work as expected. As you can see here, it still times out after about 100 seconds. Sorry, 200 seconds. So yeah, this is something that we'll need to look into.
Okay.
But yeah, let's continue with our example for now. So we are on example 12, step 2. But before we can do that, I should probably say compose up. Oh, and yes, I would need to probably start the Docker instance.
Hmm, okay.
Yeah, I'm used to running this on a Linux machine where Docker just starts automatically in the background and
Oh,
you don't
okay.
have to worry about it. Whereas on Mac, I chose not to have it start at system startup. I don't
Here's opening
necessarily
up.
always need it, right?
Yeah, exactly. I just finished updating my Docker and doing a prune also before the show.
Oh, right. So yeah, I should probably look into that at some point. Anyways, so now that we have both Olama up and Docker itself up, this allows us to connect it to the MongoDB. So if we would say make example 12 step 2, let's see how this goes. So we could connect to the database, we could process the video. Speaking of the database, let's connect the this editor quickly as well, and you can now see the magic I had to do last time. So connection here, Ardan. Yes, I know, very secure. Okay, it connected. I'll just leave all of this like that because we don't need for this example anything more. Let's pick up the example 12 database collection, and there you go.
There it is.
We can see that, yeah, everything is in the database correctly.
So that is essentially our first embedding.
Yes, that would be correct. So our first embedding made it through the database, and we can now start playing around with the idea of sending only embeddings that matter into the database, discarding the others.
Got it. Okay.
Okay, so let's see how we could do that. Let's move back to example 12, step 2. Right, so the purpose here is that we want to avoid complex computation, right? Anytime we send this to an LLM, it has the potential to work slowly or not at all, as you can see. So let's see what we were doing here. We went through the database, got all the files, sent everything to the LLM to describe it, and then to the embeddings model to get the embeddings. Now, here we would say insert into the database and so on. And if I remember correctly, we've also said skip if the, or wanted to say skip if the image is already in the database, right?
I'm not sure,
Yeah, I
but
think that, so that would be one way to do it, right?
okay,
Just query the database and making sure that if we already have the file, there's no point in processing data for that anymore.
got it.
So
Okay,
if memory serves, we do have an example for that under example 9, step 5. So let me quickly go through that. Save images in the database. And there you go. We do have this one. So all that we would need to do here is come in and check.
okay, and that's essentially checking if the file name matches, and if the file name's already in there, just remove or skip it.
Exactly. Exactly. We don't want to have to worry about
Got it.
processing the file again, both with the LLM and with the embedding model, right?
Got it. Okay.
So that would already considerably speed up the processing time for this. Let me do this because print. Oh, okay. So I guess we can keep the previous line as it was. So if we say this, then we don't need to do printf. We just need to say print line.
Got it. Okay.
Okay, so see, MongoDB will also complain about some frame trying to be inserted, and yeah, we can take a look on what's going on there. Let's run this again. Image already exists, so see, we already saved some computation time right there,
Very
and we
cool.
can see the API running.
Embeddings and
When it
completion.
works,
Okay.
it's fairly fast to describe on this machine, at least. With this particular model, it's fairly fast to describe the frame that we are looking at. So, like this 32 seconds, probably this was one of the first time we loaded the model, but then 7 seconds, acceptable, I would say. Okay, so let's see what happens here. It says
Cool. Frames.
duplicate ID1, duplicate key ID null. So let's see what's going on there. This would be probably when we try to insert the document.
Insert one.
So insert one into ID1 duplicate key ID null. Let's see how we created the index for
Okay.
this, right? Because I have a feeling that while we created the index, we may not send everything correctly here. So our index is named ID. So now I have to wonder if there's a difference here when we connect to the database and create everything in this example. So no, in this is create one index model, and then when we process the image, we still give it the same document.
Uh, let's additional.
Okay, this is interesting.
Yeah. Um, file.
Index name, vector index, create vector index. I think we are doing basically the same. Unique
Yeah.
ID. I haven't changed
Unique.
anything here. So let's see what we are trying to do here when we want to send our document. Right?
Yeah.
Let's say
Let's see.
fmt print line, and let's debug this. Okay, so this should hopefully give us a bit more insight into what's happening.
Okay.
And for now, I'll run with clear ahead of time.
And when we run this, is it starting with a blank sort of database, or does it still have that
Hmm.
one embedding?
It will have that one embedding because we see that this says it's existing already,
Okay.
but since we are trying to insert a new one, that's where it should basically say, oh, okay, you want to insert something that's new. If we go
Yeah.
back here to the database, right? So we have this underscore ID, which is the internal index and so on, and then we should have a totally different file name here, which
Yeah.
should be our index, but it's not apparently. Now the LLM should also work with us, otherwise I am not sure if we can do this.
Mm, file
So
name.
index file name. I wonder if we shouldn't use the file name here as the key for the index, because that's technically what we want to do.
Okay.
And I could drop the database. Let's do that. So when we do this, it's probably, let me see where the option is to drop the database without having to stop. Okay, well, good enough. So now if we run again, see,
Now it's processing.
it,
Okay.
yeah, that one is processing. So that part was somehow working without any problems, which is good because we want that. If I look at how we query this, it's with the file name and value. So file name and value. Let's see. I'm too afraid to look at the console to see if we have any results from the other one. But sadly, no. So we'll need to figure out how to move past this if we have to keep waiting for this, right? Because otherwise
What?
we'll need to wait too much.
Oh.
Oh, there you go. Okay, so sadly we have to see the whole embedding, but okay, let's see how it goes on frame 2. Should be interesting.
And is the wait time from the LLM being caused by like memory?
That's a good question. I'm not really sure it's memory related as much as it's either my GPU, which unfortunately this is a MacBook Pro, not a MacBook Max with those 40 fancy GPU cores. It only has like
Uh,
20.
okay.
So that could be one of the issues. The other issue could be related to either the model server or the model itself, because the vision models are a bit different than the regular models,
Got it. Okay.
with them supporting the images and so on. Right. So here it said text not found. So I wonder now what's in that image. But at least we've got something a bit more useful, because now we can actually see that all the frames are in the database.
Yeah.
Okay, so we can probably remove that debug log, and we now know for sure that our code had a bug in setting the index here.
Got
Okay. Oh, see,
it.
debugging in production, so to speak. Always fun.
Yes. Okay.
Right. So
Interesting.
let's see what the database looks like quickly, and we should have all of these here. Let's check out the images. That's a bit concerning
Yeah.
because here
Sh-
we we have these right on the first image, but then second image looks the same. Like if I look at the differences, hmm,
Yeah.
so we may need to tweak our prompt at some point to give us better results, or we may actually need to change the model. Let's see.
Okay. It's
Th- that's part of the exercise, right? Figuring out
yeah,
which model fits your data and so on. And
and it's
this one is running the
interesting.
seven.
It's interesting. It gets it on the first frame, and then it won't get it on very similar next frames.
Yeah, that's another problem with running local models. If you run them quantized, and smaller models like this one, like the 70B version, 7B version, which is only 7 billion parameters, it may decide not to do what you need,
Got it.
right?
Okay.
So as you can see, this one took nearly 30 seconds for each frame. Now, which I don't know, doesn't seem it's swapping models, so that's good. Maybe just an Olama bug.
Okay.
Okay, well, we'll have some time to play with this anyway, because now the interesting part comes in. So we have all the images processed and so on, and now if I go back and run our example again, we should basically have all of them skipped.
Got it. Very cool.
Right, nice. But let's keep them a bit more nice in terms of what we do. Let me truncate the database actually. Object actions. See, there's a truncate. Or let's just drop it because I don't want to have any surprises. Okay. So one way to do this would be we compare always to the previous image
Okay.
and do a cosine similarity and so on.
Got it.
And that's the, let's say, the easy way. And we can start with that, and then we can evolve this to be even a bit smarter in terms of what we store in the database. What do you think?
Yeah, I think so. That way I could see sort of both ways because now we're on the
Mhm.
step of actually comparing the images to make sure we're getting meaningful data, right? Sort of being put in.
Yep. Okay. So what we have to do for this one is we would always want to store the previous embeddings, right? Because that's that's the data that we are working on. So let's see how our embeddings look like here. It's a vector, and if hopefully I'm not pressing the correct shortcut. It's our slice of floats, right?
Mm-hmm.
Okay, so let's do this. We have a new variable, previous embeddings, right? And we say this. If we initialize it like this, the first value, the first time it runs, it would be nil, and we need to cover that scenario as well. But what we can do is we can say, sorry, that, do this. And now we allocate some memory for it. Doesn't matter that we don't have any values in it, but because we've done that, it's not nil anymore. It takes a bit of space in memory. The good
Okay.
part is,
So is it it's essentially a zero value now rather than nil,
uh,
or more like an empty?
well, it's an empty value now rather than a
Okay.
zero value, because in this case for the slice the zero value would be nil.
Got it. Okay. Okay.
Okay, so what's interesting for us is, let's see where we get the embeddings. We get the embeddings here, and we can say if, and then comparison, right? How would we compare it is somewhere in this package there's a cosine similarity.
Mhm.
Not really sure why it's called vector 2. Oh, I know why it's called vector 2. It's called vector 2 now because we are using the variable named vector. So
Okay.
if we change this to embedding, I don't know the shortcut for renaming stuff in on Mac. I need to get more mileage with the editor.
Gotcha. I think
That's why
it's like
you'll see me.
I think it's Command D, um,
Hmm,
to sort of do that, like select.
no, that duplicates the line,
Oh, really?
but that's fine. Yeah, I'll have a look at it later on. So
Ooh, okay.
embedding, right? And now we can say if vector, I guess it still wants to add it like that. So cosine similarity, previous embedding versus the current one,
Hmm. And then
and
okay.
the message looks good enough, right?
Got it. Okay, so it's if it's over like 95% similar, then we're just skipping over
Yeah,
that embedding basically.
exactly. So now what we can do is we could tweak this a bit. So let's say similarity trash. I think that's how you spell it.
Uh,
And
it's with a THRE.
oh yeah, yeah. Right. Let's say similarity threshold is what? So the ID suggested 95. We could do 0.80, right? Just to keep things a bit different. Now, with with this in mind, let's explain a bit what we are doing here with cosine similarity and so on, because
Mm-hmm.
this may be a new concept. So there are two ways to compare vectors, either by their amplitude, so you'd have the Euclidean distance in that case, which allows you to figure out how big the vector is in relation to the other vector,
Okay.
or you would have this cosine similarity, which would allow you to say how different is my vector pointing to a region of space compared to the other vector. So if you can imagine this in, let's say, 2D space. I don't know if we have access to. Oh, sorry for this.
I'm not sure if there's an Excali draw in this
Yeah, if it's not, we can create it. Excali draw file, because that would make it more easy.
for sure.
Draw. Okay. So let's imagine we have this here. It's our space. Let me draw this a bit bigger, right? And then we have our other axis here,
Hmm.
right? And then finally we have our z-axis somewhere here that allows us to have the space, right?
Yeah.
So let's imagine our embeddings are clusters somewhere here, and so on. So for the sake of our discussion, we could say that this is, I don't know, let's say Go routines. And I don't know if it's the correct spelling or not, but good enough.
Yep.
This would be channels, and this would be the garbage collector as, let's say, topics.
Okay.
And our embeddings are basically a way to describe these Go routines or channels or topics in general using features. And those features are represented by these vectors here that we print truncated because we don't want to see them. In this case, we have 1024 features, meaning we have not a three-dimensional space, but we have a 1024 dimensional space. We
Got
can't
it.
represent that, right?
Hmm. Yeah.
So for simplicity, let's imagine that the vectors that we have, we receive from this embedding call, now are pointing towards, let's say, Go routines, but they're pointing like this, not straight to, somewhere like this. Now we may also receive another embedding that's pointing maybe a bit more straightforward to the Go routines. But what we can also do is receive a vector that's pointing towards, let's say, channels. Now, the Euclidean distance would measure, let's say, if how different these are in terms of magnitude or
Okay.
size in simple terms, whereas the cosine similarity would get us the distance between where they are pointing to, so to speak, the difference in space,
Got it.
if you
Okay.
will. So it would tell us this embedding here is pointing closer to this rather than to this. So that's
Oh,
why
okay.
you'd have that threshold of point, let's say 0.8, because if this would be any closer, it could be somewhere in here, right? But
Got it.
if this could also point somewhere towards here in the space towards us, let's say, right?
Yeah. So it would
So
so it's comparing that distance between the other vectors themselves, not the clusters.
uh, yeah, more or less, it's comparing the direction, if you will,
Okay.
of the
Yeah.
vectors. Are they pointing towards the same region of space, or are they pointing towards entirely different regions of space?
Got it. Okay. Yeah.
And
Makes sense.
yeah, now it's 2D, 3D, depending on how well you can imagine the space and so on. But yeah, basically that's what happens here. If I would point, the more I have a difference in the space, the bigger the difference that we would have in the cosine similarity. The closer they are, the narrower the difference would be, so the higher the cosine similarity would return.
Got it. Okay, that makes sense.
And all of that happens now in the 3D space, but imagine that happening in a 1024 dimensional space. So you'd have a lot more granularity of these clusters, but also of the embeddings themselves and the vector towards them.
Got it.
So that's how they roughly work.
Super interesting.
Now, let's play a bit with this. We can comment out for now the database part because we still want to. Actually, let's, you know what? Let's copy this and we can move it after the cosine similarity just to see it in action because we can skip the database insertion so we don't get any errors for now, and we can still see the similarity in action. Ready for
Cool.
a demo?
Okay. Yes.
Let's see.
That's, that's super
Now,
interesting.
yeah, it's fun to do. Now, what we do here is we do a cosine similarity on, sorry, on this one, on what we get from the result from the LLM itself, right?
Okay.
So we first do an image recognition, and then we do the difference on the text. So we have to keep that in mind.
Okay. So we're actually comparing the LLM sort of output, what it outputs between the images is more what's getting compared.
Yes.
Okay.
Okay. Have we emptied the database? I wonder. I forgot if we
I
done that
think
or not.
so.
May have done that, or I think we are probably doing that whenever we create a collection. No, we're not. Okay. It would be interesting to see the difference between these vectors, especially now that if you look at it, this kind of looks the same to me. So I
Yeah.
wonder what happened there and why we chose to still insert the frames into the database. So let's add that while our LLM is still processing stuff. Let's see. So we have a cosine similarity. We should probably extract this. Oh, there's no shortcut for it. That's why I don't know it. Extract, let's say, variable similarity, and then we can say, can I move this? Oh, no, I cannot move this. Sorry. I need to learn the shortcuts. Yeah. Okay, so now that we have the similarity, image similarity. Oh, there's one step we did forgot to do. Image the previous image. Let's say it's a float. Let's only output point, I don't know, 0.6 of a float similarity. And then let's change that. And you know what we haven't done? We have
Ooh.
not updated our previous image similarity. Now, the question is, do we want to update the previous image similarity to the one that we inserted in the database or to the one that we processed?
Ah,
Because while if you compare it only to the previous image, differences may be small. If you compare it to the previous in the database, differences may be a bit bigger.
yeah, you're comparing it to data that we already considered sort of meaningful and added to the DB.
Right.
Yeah, makes sense.
Okay, so let's do this. If Let's do the simple way first, and then we will figure out the rest. So previous, we do a copy, and if memory serves, source is the embeddings, and then destination is the previous embeddings. So we now move those over by
Okay,
copying the values. It should be good. And if we really want to be nice to our app, we can say make this as a 1024 capacity.
got it. Okay.
So we tell it ahead of time, hey, just allocate this much memory to it and
Yeah, so
default it to
it already has sort of that memory there exactly.
yeah. And then besides it being a continuous memory space, when you do the copy, it's gonna just copy into that space easily without having to jump around or do anything like that.
Got it.
With all that knowledge now added to our application, let's see what happens.
Let's see.
Yeah, sadly, there's no way around this part,
No.
is there?
Yeah, yeah.
But
That,
that's why it's better, if you ask me at least, to develop these apps locally, even if you have to wait maybe from time to time,
mm-hmm.
because what will happen is, well, think about having to go through all these steps and spending your credits with a remote service, or if you don't have credits and you run it in your infra, spending all that GPU time and so on to process it.
Exactly. It's worth the wait time when you need to fine tune it and things like that, um, rather than doing that on
Hmm.
a sort of paid service.
Okay. Oh, we forgot to image similar. So we forgot to delete them from the database, right?
Ah,
Aha. We should probably add some code to just remove them from the database at the beginning of the script, so we don't forget these anymore.
yeah, that'll just drop it for us.
Yeah, that would be something we need to look into. But we have more pressing examples that I want to add.
Okay.
So what I would ideally like to do is not compare the text that we receive, because this, as you can see, it's a bit slow.
Okay.
When we talk to this bigger LLM, things are a bit slower. There are some models out there, and let me see if this one is one of them, which can accept embeddings, but also not only for text, they can accept images too. So
Mm,
that would be interesting if we can send them an image.
yes.
This doesn't tell me. Multifunctionality, maybe the Hugging Face page, BG entry. Let's see, can we find anything about images?
Mm,
I am not really sure this one
English.
supports it, but we can find out. Let's see if we can find a model that. So apparently this Granite model from
English.
IBM, English language.
That's
Let's see, how big is this one? Huh,
that's
not that bad. We could
but it's
potentially.
showing like 30M, 125M instead of like let's say 8B or 70B. So is it a different sort of
Yeah,
metric there?
that's a good point. So these are lower parameter count models,
Okay.
which because they are restricted only to the English language, which is interesting because I was. Yeah, I don't think we can do this.
Hmm.
But if you
Okay.
look at this, like one of the reasons we want to use BGEM3 actually is that it supports a much larger context window. If
Got
we
it.
go back here under BGEM3, this one, if I remember correctly, yeah, supports, well,
8K. Okay. Yeah.
yeah, so
Much
16,
larger.
16 times more tokens
100
to
working
long
languages. Yeah.
documents. Okay, so
Mm,
yeah, this may not work as I want it to work, so we could probably skip that, and when we find a model that works, we will just add it as an example.
cool.
Let's see, we still have an image similarity of 0, so I wonder what's happening here because the image is not in the database anymore. We do copy that,
Mm,
right? So,
symmetry.
hmm, well, when in doubt, let's debug this FMT.
Print. Yep.
And then image similarity compared to the previous one. We can run this comparison and then we can afford doing something like this. Let's say we already have this embedding way of output. I wonder. Okay, let's take this and let's figure it out together. So
Okay.
the score is that, and we want this for the current embedding and for the previous one. So previous embedding, right? And what we want now is let's have two more of these because now we want to display the vectors as well.
Okay.
I would have thought this is. Oh, no, I'm doing this outside of the for loop. I was thinking that maybe I initialize this in the for loop, which would have been, well, fun.
Yeah.
Happened to me once. So, right. Let me. Oh, we still haven't dropped that database. We should probably look into
Yes.
doing the collection drop. I wonder if
Okay.
we already have an example for that. Let me
Maybe.
search quickly. No.
No.
Clean data?
Clean clean that document. No,
Mm,
I don't think that's
no,
DB
no, no.
related.
Nope, it's not. Oh well, I was hoping to just copy paste it. We'll have to add it. Oh, there you go. Slice out of bounds. I wonder why. Is it because it's not initialized with some values? Let's see. And 10, 24. Let's force to initialize this with 0 everywhere. Okay. Image similarity compared to previous image, 0. And then,
Well, there is no previous image at that point, right?
exactly. Yes.
Yeah.
So that's a good thing.
Yeah. So on this next one, we should see some different value there.
Hopefully, yes, if we've done this correctly. But I have a feeling that I also. No, so we only skip this if it's over the similarity threshold. Okay, so let's have a
Oh,
look.
we have
It does seem that the values are there. Oh, there you go.
yep, 98.
98% similar.
Which I guess
Nice.
makes sense because I think the only thing that changed was like one word between them at the bottom, looking at the actual
Yeah,
images.
probably. So I guess at this point we would probably need some examples that are either longer or in those 10-second span that we have, they have more changes on the screen.
Mm, okay. Okay.
But for us, this is good, right? Because it's exactly what we wanted to do. It's saving us to insert in the database of a bunch of needless files.
Yeah, so it is working. It is actually comparing the sort of similarity scores between them, or giving us the cosine
Yep,
similarity between them.
that is true. And now we can say remove that debug, and it's all good.
And it gave us the out of bounds error before because it was set to 0 when you're
Oh yeah.
doing.
So when I did this here
Yeah,
with the 0, right? Technically, the slice still had a 0 uh, value, but it could grow up to 1024 values
yeah,
without having to resize itself.
got it. Okay.
So when I bravely enough, let me see if I can undo this quickly. So when I was brave enough to do previous embeddings 0 to 3 and
Mhm.
minus, the length here would return minus, I mean, it would return 0 and then you would have minus 3 because that would be the index and so on.
Got it.
And
Okay.
it would, yeah. So, but this one exploded first. It never got to this part,
Got it. Makes sense.
right? Because there were no actual values in there.
Yeah.
Now, when I just removed the 0, from here I told it, okay, make this slice and then use fill it up with 0 values for the type this time around. So for the float 64,
Hmm.
for all the 1024 values that you have to hold.
Got it. Okay.
Okay,
Makes sense.
cool. So now we can also make this a bit better by saying, hey, this is dimensions that we are talking about because ideally in production you won't update your code so often, and you won't change your embeddings model. But if you ever need to do that, or you want to play around with different embeddings uh, to see how the models perform, it's better to just change everything in one place.
Yeah, have a constant that you can just change the value of and use it everywhere.
Okay,
Really nice.
so let's bring back the optimization loop, so to speak. And if I go here, I refresh our collection. In the database, we should have only one entry, right?
Got it. Okay.
This, however, will pose an interesting question now. Let's run it again. So here we managed to get all the way through image 4 until everything collapsed, right?
Mm-hmm. Yep.
Right. But if I were to just go back here and introduce our filter for the image,
Mm-hmm.
right? What would happen now when we run it? Oh,
Let's
well, besides this error,
see.
okay, let's see, where's my error?
But now that moved up. Yeah.
Yeah, yeah, I just wanted to skip to not insert it at all. So now it went to frame 2, and do you think it's going to insert it or not?
Mm, I don't think so.
Let's go through the code together. So we initialize this with 0.
Yep.
We go through the image, and we say, find me the file name that I'm currently processing. And if it exists, continue,
Okay. Yep.
which is file name number 2. And when we get here, instead, now the similarity with the previous will be 0 because we've never actually assigned any of that, right? So if the LLM would actually work, now it should insert frame 2 as well into the database, right? Since
Oh, okay.
our logic here doesn't take into account the fact that the image exists, but it's in the database. It's not what we processed it to be.
Hmm. Okay. I'll have
Okay,
to see it happen here. I
okay,
can.
that's fine. Let's see. I mean, provided the LLM.
Provided everything goes to plan.
Yeah, it's all working as intended, right?
So we don't want it to insert because of the
Correct.
similarity. Even though the name is
Yes,
different, because of the similarity, we don't want it to insert. But it's still going to because we haven't basically told it that not to insert it or
exactly. Well, we haven't told it that the previous image exists, which matches, roughly speaking, which is similar enough to the one that we are currently processing. So
okay.
unfortunately, I can't show you, so you'll have to trust me on this one. But we would basically need to do this, and then find res. I think it is decode document. Well, let me see. Let me see. Unmarshaled. Okay, fine. And we we can say, let me construct a document here. D1 document, D1 here, R, to decode, fail to decode documents from database.
Okay.
Otherwise, D1 should have an embedding that we want to copy now. So we want to say previous embedding. Let's see if this works. And let's make a note of this. Previous image already exists. We'll use the existing embedding as a value. It's not actually a reference for the previous embedding variable. I think that's. Let me know if it's clear enough.
I think so.
Okay.
Yeah.
Document. Okay, should be enough.
Yeah. I
Sadly,
think that
this
clears it up.
didn't work. But maybe now it does. We'll definitely need to investigate what's going on and why it needs so much time to
I haven't
work.
ran in the little bit I've ran these models sort of locally. I haven't seen this.
I think it's. Go ahead.
Don't know. The only time I saw it take long like this was when I just used every bit of memory my laptop had to offer, and it was struggling. But I haven't seen it just sit there really.
So if I look at the memory and so on, this looks decent, good enough.
It
We
should.
should still have some 10 gigabytes left, right? I don't know what the CPU load looks like, but it's mostly idle, so that's also good. What I think happens is either the model is not well optimized, or, and better said, Olama is not well optimized for this particular model to run and
Got it.
may be having some issues. If this still happens, I guess we'll just have to restart it and see what's going on.
Yeah. And it seems like after the first one, it speeds up, at least for the other ones. Um,
Yeah, let's see.
the past times we ran it.
Well, that's why I prefer to run it here, because I find it easier to restart and so on.
Mm-hmm.
We may want to set some other environment variables for it, like the flash attention and so on. We'll see.
Okay. No history.
Okay. So there's already something going on here. That's why it's odd. It feels like it's trying to do something, but in reality, it somewhat fails to do it.
Super interesting.
So now we are trying to decode image O2, and there you go.
There we go.
Compared to the previous one, similar to the previous image, and we skip it. So if I go to the database, we should only have still one image,
Got it. Okay. And
right?
that's a optimization there too, because we're essentially skipping some processing there.
Oh yeah. Well, yes and no. You still have to go. So for each image here that's not in the database,
Mm-hmm.
you still have to go and compute it
Okay.
because we are not storing it in the database.
Yeah.
But then when you have to retrieve the document from the database and you want to search for it and so on, which we could do in the next step, the database would have um, fewer items to process. For
Got it.
our
Okay.
example, which is only like what 4 or 5 files, that's not a problem, right? It
Yeah.
would find them immediately. But if you start thinking about, taking the whole class that Bill teaches, which is what 20,
20 hours, something like
30
that.
hours,
20, 30 hours.
yeah.
Yeah.
So when you start thinking, let's say 24 hours times 60 minutes times 60 well, it's not 60 seconds because we've seen it's maybe every couple of seconds, so it's like times 30, it would be 43,000 images
Yeah. Now
that
that
you'd have to
becomes
go, but
now
that's
that
only for one.
seems
Yeah, sorry, go ahead.
yeah, now that piece of code there starts to show its sort of value because you're probably reducing that by at least a couple hundred or more.
Right, so even if we save this amount, like if we let's say half the or maybe reduce by one third the number of images that we do, then the database gets leaner. And that's for one course that Beetle has, but maybe we need to process all the courses he has, and that's a lot more hours
Yeah. Okay.
to go through and so on. Let's say you have to go through 100 hours, and suddenly you have quite a bit of a difference to handle, right?
Yeah.
In number of images. Sure, these values still relatively small enough for a database. Mongo should handle them fine, and any other database should as well. But if you're a video platform that has to ingest many more hours of content, then it already starts to add up.
Yeah. Okay. That's cool to think about it, sort of the scale like that.
Yeah,
Interesting.
and keep in mind something else. Let's say your users are searching for something. You don't want to have maybe 10, 20 results that are the same, basically,
Yeah, that makes sense.
right? Because at the end of the day, if they look the same, then your search engine won't get good value for them.
Got it. Yeah, you'd rather have one correct response than, four.
Yep. Now, because of this similarity, you may lose a bit of um, content here and
Hmm.
there, but that hopefully shouldn't be made up by the way the keyframes are arranged in the video and so on. So that's an important
Exactly.
bit now.
Yeah.
Like, how
Like,
often are your keyframes happening?
yeah, like in this 10-second video where we have about 4 frames, we're probably losing, 3 out of the 4 frames. But in like a 30-minute video, you're kind of keeping more of, you're losing a lot more, but you're keeping the meaningful changes, essentially.
Yep. Now, one other thing that we'll probably need to do before we close this example would be handle this case
The error.
where we
No text file.
we have this,
Yeah.
right? Because we don't necessarily want this to reach out in the
Mm-mm.
database. So let's do that. Um, let's not even embed this because there's no point in doing that. And we could say, and I will need to segment this code a bit better after the change. So let's say if we have if results contains see, beaten by the shortcut again. Strings contains, so probably something like this with an error and so on. Not text found in image, and we want to continue.
Go to the next one. Okay, cool. Yeah.
Yeah, because there's no value in doing that.
Yeah.
Now let's see if I can remove that nicely. Okay, so we only have one value left,
Yep.
which is our initial sample frame one. And I chose to go for this whole thing here because, as you already noticed from the previous example, sometimes the JSON description wouldn't go away, and I would rather not have to deal with that for now.
Yeah.
So it's good enough.
Okay.
Okay, so
Interesting.
hopefully when we do this now, frame one exists,
Okay.
and let's see what the LLM does. We may need to restart Olama again.
Yeah, that seemed to help. Let's see.
Yeah.
Can give it a little bit of time here. Hopefully it plays nice. Interesting. So
Right, but
now we have the data going into the database. We're comparing the similarity between each frame. So what's sort of like the next step in this?
okay, good question. So let me make this code a bit more uh, segmented here because there are different areas of what they do,
Mm-hmm.
and I want to keep the format sort of similar. We would like to do this. Okay, I think we can commit the code because I am fairly sure that it's gonna work.
Okay.
Okay, there you go. That's nice. We've got a description for the second image. That's always good.
Yep. Have that.
And let's see if frame 3 should.
Oh, and then we have a low similarity score underneath, so that
Oh. Hmm. So I wonder what happened here.
image
I
similarity.
think no text. I wonder if the escaping uh, has a,
Oh, maybe it didn't recognize.
or if it's the other way around. No, error. LLM response. So I wonder if this is escaped already or not. Let's see the database. So this is already escaped when we get it here.
Hmm.
That's such a fun one. And if you look at it, it decided to be like, oh, there's a text here, and then inside the text it put the error, which
Yeah,
is
rather than just
not what
error.
we, yeah, right, because we said the out, okay, output must be, maybe that way it will.
Maybe.
listen to us.
Text message.
Format, let's say instead of similar, matching.
Yeah, more less
This one.
ambiguous.
Yes, hopefully. Um, let's remove this from the database quickly. Delete the row. And let's run it one more time. Should we let's just cancel this.
Let's see there.
Okay, frame exists in the database. That's good. A bit of prompt engineering will also need to go in within the application, right? Because we've just seen it going, oh, I want to combine the JSONs. Why not?
Exactly. Yeah, our output is sort of directly tied to how we're prompting it. So we're gonna have to do some tuning on that and see
Yeah,
where
and
it's happy.
exactly. The model is also at a disadvantage, if I may say so, because we're not using a reasoning model.
Okay.
Whereas a reasoning model may get itself into this state where it checks itself before writing the output
Mm-hmm.
and write it correctly with a higher chance. In this particular case, it doesn't seem to be the case. But at least if you look at what's happening now, oh, we've got basically everything done.
Yeah, and we have
We say,
values for everything too.
yeah, we only have 4 frames now, but it says image exists. This is similar. Um, Unfortunately, I can't test the not found stuff, but if it shows up again, we'll see it and we can build up
Yep.
on that one. Cool. I would say let's commit this and move forward.
I agree. That's cool though.
Yeah, cmd and then make file without a example 12 to the database. And let's push. So you may notice I'm pushing now to a branch instead of main, just because if I need to do any cleaning before pushing it to main, it
Got
would
it.
be
Okay,
easier.
yeah. I wasn't sure if we were doing this in a branch last time.
No, I just forgot to do it. So yeah.
Okay.
Okay.
Cool.
So now we have the data in the database. Let's see if we have time for one more trick today. And that one is, let's say, talk to the database, which we can fortunately borrow from all the other examples that we have. Let me double check that here we said Olama compose up perfect, and then here Olama and compose up as well. Builds on and shows you how to interact with the data. Okay, step 3. Okay, let's go. So
Okay.
Bill has one of these really nice examples of chat
Uh-huh.
happening. If you remember the make example 10 step 5.
Yeah.
Hello
That's
model, right? And this is, I think, much nicer to interact with and so on, and also would give some value to our application.
yeah.
So if I say bye, okay, and now let's close this. So let's see if we can take apart all of these and move it to our example. So we have some tool calling here, system prompt. So this I wouldn't get for now. Let's see what's in the run. So we have the conversation.
Yep.
Let's see what we can do here. So we have the prompt to process the video, and then we have all of this to get into the database. At this point, what I would do is I would take everything from this run function
Yeah.
and call it something like ingest video, because that's really what it does. It takes all the video, processes it, and then either dumps it to the database or not. So I would say ingest video, right? And I would just build a new run function on top of it,
Got it. Okay.
right? Because that would allow then for us to have different segments, and if we
Mm-hmm.
want to reuse the code, it's easier
Got it.
as well.
Okay. Because we're gonna need to have a chat loop now, essentially happening.
Exactly. So if we have that chat loop, might just as well take it out and see how we have this agent now,
Yep.
which basically has a lot more stuff going on. We can probably do the same here as well. For now, I don't think we necessarily need the agent,
Mm-hmm.
but we can easily turn this into an agentic code as well. Should
Okay.
we start building on that on the agent and then just use the chat function for now without registering tools, or should we just do
I think
the chat?
we I think using it without the agent initially and get it working, and then we bring in the agent would be sort of like a good plan of attack there.
I agree. It sounds good. So let's say if let's continue the tradition chat loop. Okay. So now we have the chat loop stuff. Let's go all the way here at the bottom of the screen. Chat loop. It's almost like it knows what I want to do with it. Okay. So see, I would like to get some of those tokens as well.
Yeah.
So at this point, I wonder, let's study the code a bit together. So all that we would need to do is actually easier if we take the agent code and not register the tools. And
Okay,
we would
I
get
see.
all of this for free. So
Yeah.
change of plans, basically. But that's
No, that
fine.
makes sense.
What we can do here is we can say agent, because we want to build the agent maybe a bit separate from the main function.
Okay.
Right? So let's see. We would need to get the type for the agent. Let's bring in code as we need it only.
Yeah.
Tools.
Which I
Should
think, yeah,
we add
the
tools?
interface. Mm,
Let's not add it, and we'll see later if we need it for now. So
Okay.
for now, we can say just this without any tools. Without any tools.
Sure.
Nothing is lost really here. We need to register, sure, but we don't have anything to register yet here. So now that we have the agent, we would have this system prompt, and then the agent has this run function, and we can go through it together and see what it does
Cool.
and see what we need to keep from it and what we discard. Okay, so that's a bunch of red code right there.
Yeah.
Okay, so conversation content, that's fine. In tool call, I would keep this for now, just because I'm not really sure what it does. System prompt, let's bring that over here as well, but we may need to change it
Yeah.
because now we're not a coding agent anymore. We are a video platform.
Makes sense.
Let me put it in a better spot at the top of the file to make it easier to find.
And you generally put your constants at the top whenever you're working.
Yes, yeah, I tend to have a structure where I have the struct types first, and then constants, variables, and so on,
Makes
and
sense.
then the functions and models.
Okay.
But that's just me. Depends on
Yeah, it's
everybody.
preference.
So, some people I've seen putting constants, let's say here, before they are used in a function, which also is a valid way to do it because it's closer to the to the usage place, right?
Yeah.
You are a helpful assistant for a video. Not really sure which tools.
Yeah.
We have reasoning high. Users will ask you about content inventory. Can retrieve using. Aha, so we do have a tool that we need because we would need to somewhat
Oh
go
yeah,
to the
it's
database
yeah.
and fetch that, right?
Yeah, so it would make sense to have a tool here. Sort of do that.
Yeah, do not use any of your knowledge. So that's not in the library because
Okay.
we want to restrict the knowledge of the model to only what's in the library, right?
Exactly, yeah. We don't want it hallucinating anything.
Yep. And let's see how Bill is handling the tool calls here. So after you make a tool,
If the call will succeed or
okay, we can take this. Sounds like a good idea. Using any of available tools,
Mhm.
right? So we have a bit of structure for those.
Yep.
And when reading Go source code, we don't need that. Yeah, do not verify those results. I wonder why is this one is here, but probably it's within line of this one as well. Let's see. And then we instruct the reasoning model to use a higher level of reasoning. That's good. So it turns out we actually do need this because we want to register that tool. So let's see where the tooling is. Okay, tools. And then I'll let the tool for now not be here, just because I want to make sure that we are getting the rest of the stuff. We probably want these as well then, right? Since we want to add to the conversation and have the tool calls done as well.
Okay.
And let's see what's
Yep.
missing. Context window. Okay, I don't think we have any context window here defined. No, we do not.
No.
So that's fine. Context window. Let's just take this, move it here.
Okay.
Oh, sorry, it's a variable. So let me undo this. Wonder if we do any processing on it. So let's see what happens. Current window. Okay, fine. Doesn't seem that we override it with an environment variable or anything like that.
Oh, okay.
Yeah, I was looking to see if there's any other processing happening. So let's see. Chat with. What's our model named like? Model chat. Okay. We probably should change this. So this would be
Yeah.
model vision, because I want to use that GPT-OSS.
Yeah, for the chat model.
Right? And then model chat. And let's see, the model is this one.
Yep.
It all comes together. Now, I know there's a shortcut up there to do this line movement, but I don't know which one it is. Let's see. So most of the changes are because we changed the name of the variable, but that's fine. Okay, the URL. Now the URL should be chat URL.
Yep.
Condition is always true. I wonder why. Oh, well, yes. So condition is always true because this is always going to be evaluating it. And when it gets here, it's always true. That's fine. Okay, so let's see how new agent is used. Really quick, we say this, that, agent run. So we can take all of it, really.
Yeah, because
Except the
that'll be our
name.
new agent. Okay, so that will live
In the chat
let me
loop.
see. In the chat loop. Okay, yeah. I don't know the new name we had. Okay, so chat loop. Yeah. And then now we'll have the chat loop call in the run function.
Exactly, because we already do some processing here, right?
Yeah. Okay.
While we are at it, I know we are talking to the database here. Let's let's change the name to this, and probably instead of frame we should call it step.
Okay.
Let's do a quick refactoring here as well to keep it all nice and tidy. I don't think we didn't.
Yeah, we didn't have DB there yet.
Okay, because then, and let me just make sure that, yeah, all good here. Good. So we are at the point where we are almost done. We just need a function for the agent.
Okay.
So let's see how functions are written. Okay, so I see there's a let's actually go here. So new agent, right? Probably this would be the easiest one. We need
Yeah.
to register the function, right? And let's go do just that. So let's keep the formatting consistent, and instead of register file, register db search.
Okay.
Because we just want to register a function that searches in the database. Now I see Bill also created a new file, so I'll just functions to follow on his formatting.
Yep.
And let's see how register file works and what we need to do to add it. Now, this becomes register research. DB search tool.
Yep. And then provided tools.
Okay. So let's see. Funny symbols. Tool database search. So we want to give it a really good name. I'm not sure if we want to change the Go name as well to match here, because we know what DB is, but
Yeah.
for purposes of the agent, we want that to be as explicit as possible.
Because that helps the model also sort of decide when to choose it, right? It takes that name into account.
Exactly. Exactly. So the more explicit we are, the better the chances for the tool to be called. Okay. To read the to well,
Okay.
okay. So tools, we are doing this, we are doing that, and then it's missing. Sorry for that. It's missing the tool document
Yep.
function and the call functions. Let's bring them over here, and then we can work with them. Search.
Mm-hmm.
Okay. And we need to bring in tool error response, and tool success. Let's find those as well.
There they are.
Okay, I think they may have a separator as well. Let's bring that over as well. Nice.
I need to figure out what the option is for the collapsing of like the functions. Just like for copy and pasting, like what you're doing, it's amazing.
Yeah. You can even do types and so on. So, like when reading the code, if you don't need those, just hide them and that's it.
Oh, that's awesome.
But we do need to read them now because read the contents and searching for a file. Okay. So we do need to change this a bit.
Yeah.
And go ahead.
And we should probably change it from RF to like DS or something, right? In the receiver.
Oh, yes, that's a good point. So let me see. Context actions. Nope. Rename all receivers the DBS.
DS.
See? And RF here,
Yeah.
since we are refactoring this, DBS. Sorry, DBS. Yeah, good point. Good catch.
Searches
So,
names.
content. The content to look for in the database. And I don't particularly enjoy this structure, but once you get it, it's easier to read.
Yeah, is that like the standard structure? Because I sort of had the same thoughts about it. Like it took a little bit to understand. Um, is that like the standard structure for this like tool calling? Or
Yeah, this is the standard structure for an OpenAI compatible API, if I
okay,
remember correctly.
okay.
So, because OpenAI were pioneering this, and
Mm-hmm.
everybody kind of wants to be, the platform that's easy to migrate from OpenAI to, then kind of
Exactly.
everybody adopted this.
Got
So
it. Makes
here we are.
sense.
But if you look at it, it kind of makes sense. Like you have a function and then you describe the function, give it a name and some descriptions and so on. And when you structure that to the LLM, it sort of starts to make sense, right?
Yeah.
In
Um,
here.
the one I was a little bit confused on was I guess like the required, whether it was like required or not. Um,
Oh,
like that
yeah,
was a little bit confusing.
I see. So, yeah, so this one, I mean, yes, it could be a bit confusing, but if you have multiple parameters here and you only need some of those, you tell the LLM which one of those are required parameters.
Got it. Okay. So like the if you had four and you only needed two, you could, just make two of them required. So the LLM would call the tool if it only had those two that are required.
Exactly.
Got it.
Yeah. So,
Okay.
for example, think of the get weather tool where you would have, let's say, location, which would be
Mm-hmm.
one parameter, and then maybe the time of day, if it's morning, afternoon, evening, something like that.
Yeah.
You could say, hey, what's the weather in New York, and then it would provide you the date in the weather in New York. But you could also say, hey, what's the weather in New York this afternoon,
Yeah. Now you're giving it
and then
a time. Got
yeah,
it. Okay.
exactly. So it could be a bit more explicit and so on. Now we need to change this a bit because we've changed from path to content
Mm-hmm.
here and here, content, and we would need to search the database and be able to return something. Now I just so happen to know that there's a vector search in here.
Yeah.
Wonder if we can just take it from here for now. LLM embed text, and yeah, I guess we can just take it.
Okay. So when it does the search, it also needs to embed the question.
Yes, that's correct. So your question also contains the features, right? That you want. And
Yeah.
for now, we won't do any advanced processing on the question.
Mm-hmm.
So we'll just try to keep it of like what's on the screen and so on to get the good results. But
Yeah.
yeah, basically you'd need to vectorize that and embed it such that we then use MongoDB to have that uh, match done for us.
Got it. Okay.
Fortune, Fortunately, we have most of these already figured out. So that's why we can make this progress here. Let's see, where's the search result? Now, the question is whether we put this into the main function or not. I guess we can put it here. And then let's move it. Okay. So now we have a bit more structure to our code. We can search the database and let's do that. How is it? How is this one called? Let's see.
Search results.
Yeah, so we get a question and then I I don't think we need this part. We just need this. Let's tool call content directory. So this would be the directory. Let's say content here. If the content is nil, or well, better said, is not empty and so on, we assign it. And if content, yeah, I think we can say that,
Yeah.
right?
Content
We
is
could say
required. Yeah.
content is required. For now, it's fine. And then let's do our, what was the function to error response? Yeah, okay, that's fine. Vector search, we'll have some data to retrieve here, but that's fine. Let's refactor the response first. So we could say here print f turn, and then let's get the error. Oh, sorry for that.
Oh, error. Error. Yeah.
Yep, and then that should be fine. And then let's see how would we structure the content here. So if we go under our tools here, let's take a look at what build does.
Mm-hmm.
We have the structure call, let's say call filter files. So basically what happens here is we just send the data and then this should be a key value from what I can tell.
Yeah. Key value.
And then for the tool, we take that data and we feed it back. So if we go back here, what are we interested in displaying? Let's try to figure it out. So for each search result, we want to know if here we wanted to know the files, right? So we basically had a slice of files and each file name.
Mm-hmm.
I think search results could be for us the turn value. It's a map string with the file name and then whatever data we have about like the description
Okay.
of that. What do you think?
Yeah, that makes sense to me. So give us back the file name and then the description. Okay. Yeah. Because we're
Okay,
not going to just display that to the user, right? There would be another step where the now like the OSS model basically gives us like a cleaned up response.
exactly. And we can take the LLM and let it do the cleanup for us.
Yeah. Okay.
Cool. So we are really close to getting it done. We just need to get these questions. Well, question, that's easy. It's the content. LLM embed text, which is the LLM client. So we could say DBS, DBS LLM embed and DBS column because we don't want to instantiate all of these always,
Okay.
right? So now we would need to potentially change this a bit. And let's do this. Let's see. Which are the function, the data types here? LLM and collection. We just moved them to our register function here,
There it is.
right?
Okay.
And we can say LLM embed. Let's call this embed 2 because we want to be nice and have a good name.
Mm-hmm.
And I guess option create. Okay, so now we just need to fix the call to register this, which is LLM embed and collection, which guess what? We can either instantiate or we can get from the other application. For now, because we are spinning up a new agent anyway,
Yeah.
and we don't want to deal with all of that, we can go to our main function, LLM embed. We can take this again, and we can say this, and then the database call comes from init
Yeah.
database. We'll
Yep.
just do this.
Okay.
Connecting to MongoDB and so on. Now, later we may move these outside, but I just want to see it
Okay.
working first.
Yeah.
and we have the context to play around with. Now, this context will cancel itself after some time, which is fine for our example, but we have to keep that in mind. So, we say this, we say that, agent, we just need to return some nils here. Connecting to MongoDB again. Don't need this anymore. Shouldn't need that. And if everything aligns, you know what I haven't done? Make
A new yeah, a new example, new
a
step.
new step. Okay, so let's go. Example.
Undefined new agent.
Why am I not surprised? New agent. Oh, I know why. So here's a quick one.
Mm-hmm.
In running the example, we do this, but we probably want to just, because we want to include all the
Yeah.
Go files, right?
There we go. Okay. Cool.
Okay. Have we cleared the database? I can't remember.
I
I
don't
guess we
think
must
so.
have. Oh, we did. So,
Oh, okay.
processing image frame 001. Should have skipped over it.
But it shouldn't be in frame 2, right? It should be step 2 now. Under collections.
Wait. Oh, yeah, you're so right about this.
There it is. Yeah.
Yes. Sorry for that. You are right. We've changed the database a bit.
So JSON
Nice.
service.
See, someone is
Okay,
paying
cool.
attention.
No, I'm learning a lot today. This is awesome.
Okay.
No text
Look,
stuff.
there you go. We have
There it is.
a low similarity and so on. And I wonder what was this model thinking?
Yeah, because it found it before with the same video. Huh.
Well, but you can now see that the similarity is way off,
Yeah.
and it's still trying to insert it into the database. That's because the similarity is, yeah, that's good. It was right to insert it. The problem, again, with us not detecting this error correctly.
Yeah.
So it says, oh, it's way off. Let's include the frame 2 as well,
Mm-hmm.
right? And now frame 3 will be different because the new previous frame is frame 2,
Yeah. Oh, okay.
right?
And then now it's comparing to that. Okay, that makes sense.
Okay, so now let's say, I don't know, server mux or hello model. Let's load the model first.
Okay, models there.
No tool needed. Um,
Now, how do we
for
word?
content about, um, let's say new server mux, or, well, sorry for this. Can I go? No, I cannot go back. That would be too easy.
Oh well, it did the tool call.
Yeah, we need to search about new server max tool search db search, and there you go. It searched only for the content we needed. So that's the reasoning model power.
Nice. Okay. We need to answer what
And
is
then
that? And it's giving us the code.
yeah, because we, well,
Yeah.
thanks to us embedding what's in the image,
Mm-hmm. Yeah, wow. Just like that,
there you go.
magic. What?
Yes. So
Oh, that is
now
awesome.
you can imagine yourself building something like this for, well, technically any video, right?
Yeah. And now it can get now it doesn't have your audio transcription, but for the video itself, the images within it, like that's insane to be able to do that.
Yes, and you know what? There's a whisper. So let's ignore this. If you read the news, yes, sorry, I will pay for you later. Um, if you read the news, FFmpeg, the latest version that's going to be released in a few weeks or maybe a couple of months at most,
Okay.
gets an exciting new feature. Now we could do this through an LLM call ourselves, but since we already know how to use FFmpeg, it would be just a matter of running a command like this one,
Like
right?
that
So
there.
let me
Yep.
see if
Yeah, yeah. That's good size.
and yeah, and you get the transcription for free for English and so on and so forth. But yeah,
Wow. That is really
and
cool.
then exactly, then you combine that with the power of the image search as well, so you can now search properly through the whole video.
Exactly. Yeah, not just the transcripts, which I feel like is the more common sort of use case, but to do the actual sort of, I guess, frames of the video. I haven't seen that before.
Yeah, and all the code you need is, well, this one here, really, that we've built. And with that being said, let's say thank you. And let's push this to the repository because I think we are running out of time.
Yes, we are overtime.
Ooh,
Just a little
as
bit.
usual,
Yeah.
I'm keeping you over time.
No, that is super cool to see that sort of working. Wow, that's interesting. That's interesting.
And that's it. Cool. So
Wow.
this is in the branch. It will make it to the main branch in a few days at most. But now we have the base for it. The next step would be adding, as you said, the audio transcription as well. We can do that with Whisper today, and in fact, there are other tools as well, like Faster Whisper and so on, which
Okay.
we could play with
Yeah, that is awesome.
if you want. But keeping in mind that FFmpeg already gained this capability, maybe it's worth pulling the latest version and just saying build with this enable whisper flag, and yeah,
That's it.
you go
Yeah, then
having
we're
fun.
already we're already using it, so it would keep it consistent. Yeah. No, this is cool. My mind is just going like all over the place with how crazy it could get.
Yeah,
That's awesome.
imagine building your own video library now, right? And being able to search through the videos that you've never had transcriptions to. And
Yeah.
not only that, but maybe you want to say something like, hey, I want to get all the videos that I had when I was in some random place, right? I don't know, New
Yeah,
York,
and
let's say.
now I can sort of recognize that.
Yeah,
Wow. Very cool. Okay. So we are completely out of time, but I appreciate you
yeah,
going through that and sort of teaching me a lot along the way. It was really cool to see um, that example sort of come together and do something pretty cool.
cool. I'm happy I could help you. Let me see if I can turn off the screen sharing.
Yep, yep, right here. Alrighty, so thank you to everybody who tuned in. I hope you guys enjoyed, and we'll be back next week.
Yeah, thanks, everyone.